Assalamualaikum and hi everyone. Today we are going to present our project entitled Movie Collection System. Before we begin, let me introduce our group members. My name is Nur Syaza Amani binti Suhaimi and together with my teammates Ahmad Muqarrabin, Muhammad Izzul Luqman, Muhammad Amar Khaizurai, Muhammad Amirul Hafiz and Nur Azmina Farzana. Moving on to our table of contents on page 3. Here is our roadmap for today. We will be going slide by slide through our project description, marble sort sorting, linear search complexity, performance matrix, modular architecture, and program demonstration. To give you the initial rundown on page 4, our system is an array-based C++ application designed to make managing a movie library completely simple and menu-driven. Our code handles core collection features like adding movie, sorting by release year or star rating, and finding specific records. To ensure feature maintainability and a clean design, we structure the entire apps around a modular build.
If we move to page 5, we can see the logic behind our chronological organization, which use a classic bubble sort algorithm. In our backend code, the system runs nested loop to look at two side-by-side movie. If a movie release year is greater than the one next to it swap their slot in memory so the largest value bubble up to the end. Then on page 6, we look at how the system find movie using linear search. For our general search, it traverses sequentially from index 0 to check for exact string match. For title search, we make a little bit smarter by using a substring match, which let user find a movie even if they only type a partition keyword. To talk about the system performance and efficiency, let's look at the next page with.
Thank you, Muhammad Izzul Luqman. Looking at page 7, our performance matrix maps out our algorithmic efficiency. Inserting a new movie record happens instantly at a constant time of 01. However, because we are using a standard array structure, displaying entries or running a search loop requires a linear scan, giving us a time complexity of ON. Our bubble sort is our heaviest operation, is at a worst case of O2 square due to the nest loops. But crucially, everything runs at an in-place spatial footprint of O1. To keep this code base completely neat and clean, page 8 highlights our module architecture. We broke the programs into three distinct files. Firstly, movie.h. It stores our structural blueprints, holding our custom movie struct and our save max movies equal 5 boundary caps. Secondly, movie.cpp. It houses our actual logic, implementation loops, sorting and searching. Thirdly, mains.cpp. It acts as our user dashboard, driving interaction through a do-while loop and switch case blocks. Now, let's jump straight into seeing the system interface live with Nur Azmina.
Thanks, Mukarrabin. If you look at page 9, this is the command line interface a user sees when they launch the application, offering a clean numeric menu to control their library. Moving to page 10, let's look at our first function, adding a movie. Here, the user interactively enters the title, genre, year, and rating. One critical we added to our back-end code here is seen ignore statement. In C++, switching between reading numbers and reading string tags can cause trailing new line characters to clog the input buffer, which accidentally skip lines. This simple buffer cleansing ensures the user interaction stay completely seamless. If a user tries to add more than our array capacity, our boundary logic safely locks them out and print list is full. Let's look at how the system prints out these movies on the next slide with Ammar.
Thanks, Azmina. Next, we're flipping over to page 11. Selecting choice 2 will pull our store movie struct directly out of memory and aligns them beautifully into a readable table. As you can see, the system cleanly output each stored entity, organizing the data by its corresponding number, title, genre, and year for easy viewing. Now look at page 12. When a user chooses tree to sort by year, the system cleanly triggers our background sorting logic and prints out our success confirmation. We can see from the terminal comparison on page 13. On the left side, the data is entirely randomized based on when we input it. But once the sort is called, you can see on the right that our bubble sort is successfully shifted the Cold War 2012 to the very top, organizing our array flawlessly. To take us through our final function and conclude the presentation, here's Amirul.
Thanks, Amar. Finally, let's look at page 14, which showcases our search output. On the left box, when a user enters choice 4 and looks up the genre horror, our linear search sweeps the array blocks and seamlessly filters out both Corinne and Suso together. On the right box, you can see our error handling in action. If a user searches for a genre that doesn't exist in our current collection, such as action, the program handles it gracefully by printing out clean, not found alert. For page 15, the demonstration video will be in Struct by myself, Muhammad Amir Hafiz, and my friend Muhammad Amal Kaizuran. Let's go.
Assalamualaikum, my name is Muhammad Amal Kaizuran bin Muhammad. I will show you the demonstration for this system. For the first choice, you can enter the title for the movie. For example, for it, the genre is horror and the year is 2022. And to show the current movie, choose 2. So the movie that we just entered will appear in display.
So I will continue the demonstration. As Amal said earlier, that when display all the movie, after we edit, we will see the movie is not sorting by year. As you can see, for Corinne, 2022 and Top Gun 2019, sorry, and Angry Bird movie 2017. Yeah. So for sorted by year, by movie year, we will use the third function, which is sort movie by year. And it will display sorted by year. And when we display it, all the movie is tersusun apa? Sorted by year. All of it. Like 2017 until 2026. Yeah. So for the fourth function, search movie by genre, enter genre to search. I will type such as horror, and it will display found 2 movie, which is Corinne and Suso. For example, I will search musical genre. So it will display not found, the movie. That's all for demonstration. Thank you. And let's bring our slide presentation to a close. Thank you so much for your time and attention today. That's all from us. Thank you.